What's going on, ladies and gents? I hope you're all doing well. So before we hop into the lesson, I thought that actually be really beneficial if we do some quick announcements at the beginning of each video. Now, I know some of you gave us feedback that you say we gotta just get into the lesson. However, we're also noticing a lot of you don't know about certain things that we're posting that answer a lot of the questions that we've been getting for this past week. So please bear with us. I am going to go through a couple of things. So something that we just posted, well, for me, not too long ago, is when you go to Google Classroom, just as a quick fun fact, and I know you know this, but I just want to make sure, when you look at your classes, now for me, you see literally every single algebra and geometry class that exists at BTech, but I know when you look at your classes, you get to see all of your assignments that are due for those classes. Okay, so when you say, like, I don't know when things are due, before you even get into the class, you can see this like little kind of like to-do list for each class. That's number one. Number two, when you go into your class, now whether if it's algebra or geometry, but of course, you're only going to see geometry, right? You're going to see the following. On the stream, it says recommended math schedule. A lot of you have been telling us that you would like that you're struggling with some kind of schedule so that you kind of stay on time. And a lot of you also asked for extensions this week, like a lot of you. And again, like there's nothing wrong with extensions, but it's a little something when like you get like asked at like 11:50 at night, the day it's due, right? So two things. Number one, starting Tuesday, which is when you're gonna hopefully watch this video, if you need to request an extension, you need to make it before 12 noon on the Sunday that it's due. So this coming Sunday, if you're like, oh man, something happened, or I just need a little bit more time, you gotta ask us before noon. You can't ask us last minute, okay? Number two, Ms. James created this amazing calendar that kind of just summarizes everything that you should do throughout the week, because we know a lot of you don't start the assignments until Sunday. And if you do that, that means you're doing like 3 assignments in one day, and that's a lot of work. However, if we're giving you the stuff on Tuesday and some stuff on Thursday, we're kind of breaking it up for you so that you don't have to do it all in one day. So I encourage you, pause the video and check out this chart. Let's just jump into the lesson. And today, the aim for today is what's more to learn about tangent lines? So the last time we heard the word tangent is when we were talking about trigonometry, right? Sine, cosine, and tangent. And the funny thing is that all of those things, every single one of those things do have to do with circles. Now, we don't learn that in this geometry class. You actually learn some of this in Algebra 2. But we're going to be learning about the word tangent, okay? So the learning objective for today is we will be able to determine and use tangent properties in circles. So we're going to derive the relationship between tangents and radii. So that's like multiple radius, right? And we're also going to derive and use the relationship between two tangents that meet outside of a circle. Now you're probably like, what does all this mean? Don't worry, we will get there. All right, so week 2 password. Just kidding. But some point in this lesson, I am going to stop and I'm going to give you the password for this week. Last week, we kind of gave you multiple times that you could resubmit the survey. Not this week. You need to watch the entire video, and I'm going to try my best to make this video a little bit shorter. But remember, we're putting together 2 lessons, okay? So it's probably going to be between 20 and 30-ish minutes. But I'm really going to try my best to make it shorter. Okay, so I don't know about you, but I've been playing a lot of Call of Duty Warzone. So again, if you don't play this game, don't worry, it's not going to actually change how you're going to learn this lesson, but this is actually a really cool thing that I was thinking about with my friends. So this is kind of what happens. In Warzone, this is the map that you see. And this circle, I'm not going to go into details, but this circle is kind of like your safe zone. And what happens is on this blue line, you travel in an airplane. And without going into details, right, you got to jump out of the airplane to go to a specific location that you and your team wants to go loot and, you know, scavenge for weapons and stuff like that. So I was playing with my friends last night, and my friend called out, okay, let's land at quarry. So quarry is over here. It's marked with this like little yellow thing. And my friends, again, we're in the helicopter. We're by this green arrow. My friend was like, yo, let's jump over here and let's fly with our parachutes down to quarry. And I was like, Eric, like, why should we jump there? That's so far away. So let me highlight that. So he wanted to jump out of the airplane right here and travel this distance. Okay. But I was telling my friend, I was like, bro, like, that doesn't make sense. Why don't we do the following? Why don't we continue on this airplane and keep going and keep going and keep going until we get a little bit closer? So my other buddy was like, okay, we'll jump when we're around the hospital area. So I'll do this with a different color. And again, if you don't play this game, don't worry. You're still going to get the answer in the end. Just hold on. So my buddy wanted to jump off at the hospital area. And he was like, yeah, that's closer. That makes more sense. So I thought to myself, me being the only math person in this Discord, right? I was like, well, what is the shortest distance between a point and a line, right? So how do you know what is the shortest point? I'm going to do it for you, and I want you to see if you can kind of make any claims or any conjectures in your mind of, what I came up with. So I'm going to perform the stuff that can actually get you the answer, and I want you to think about it. All right, we're back. So the orange line happens to be where you need to be. That is the shortest distance. So if we jump out of the airplane at this marker and go straight to our location, this is considered the shortest distance. You might ask yourself, well, why is that the shortest distance? And we'll get there. But here's a fact for you. The shortest distance between a point and a line is a perpendicular line. So if you're trying to go to a location or a point, let's say it's on a map, and you're coming from a line, the shortest distance is always going to be a perpendicular line. Any other line that you try to create from that blue line is going to be longer than the orange line. Now you might tell me, Mr. D'Souza, in real life, if you're jumping out of an airplane, there's like wind resistance and all these other things. You're right. Geometrically, if we're just looking at a graph, that would be the shortest distance. So if you're playing Call of Duty Warzone, if you're trying to get to a specific location the fastest in terms of, I guess, distance, I would say, it's always going to be, you have to be perpendicular, or your flight path has to be perpendicular to the location, which I thought was pretty cool. Now, I want you to keep that fact in mind, okay? You don't necessarily have to draw the entire map. That's silly, but the shortest distance between a point and a line is the perpendicular line that connects them, okay? All right, so let's get into the math because that's going to connect in a little bit. So tangent to a circle. When we say a line is tangent, okay, no matter how far it extends, it intersects the circle exactly one time, okay? So in this context, what it means for a line to be tangent to a circle is that it intersects the circle, or remember, instead of the word intersects, we can also use the word touches. Okay, so it only touches the circle exactly one time. And you can see in this picture, so it's kind of like it lays on the circle, but it's really only touching the circle at point A, okay? That's what it means to be a line tangent to a circle. So let's actually do some cool stuff. All right, so in exercise 1, what I would like us to do is we have circle M, and we have 2 lines that are tangent to our circle, M and N. And the points B and C, respectfully, are like the points of tangency. So I actually should write that out. Points of tangency. So points of tangency is essentially when you have a line that is tangent to, let's say, a circle in this case, it's that one intersection point. Awesome. So we're going to follow a couple of directions and see kind of where we're going to go with this. I think this is actually really cool. And again, I'm sorry I don't have more examples, but I'm being so honest. I was playing Call of Duty last night with my friend, and I was like, OMG, like this completely connects to what I'm kind of be teaching this week. So if you do play Call of Duty, or you do remember the situation of like jumping out of an airplane, and parachuting down and all that kind of stuff. Try to see if you can try to see the connection with what we're about to do. Okay, let's jump into it. So the first thing that I want you to do is want you to draw radii that creates AB and AC. So I'm going to use my line tool. So I have AB. Let's do that a little bit better. Actually, that's fine. We have AB and AC. So I want you to think to yourself before we do anything else, what appears to be the relationship between the tangent lines and those two radii? So again, I encourage you to think for yourself before moving on in the video, okay? Lines are infinite, so that tangent line M and the line segment AB, those are not gonna be congruent. They're definitely not parallel. They could be different relationships like that. But if you're thinking along the lines of, you know, parallel, perpendicular, intersecting, tangent, all those types of things, you are on the right track. So let's actually kind of go further. I'm going to redraw the picture. It says locate a point D on the diagram from exercise 1 anywhere on line M. So all it's saying is, you know what, let's just draw another point. So let's draw a point on M. Let's do it over here, okay? And then the question that it's asking us is the following. First, we got to connect it. And the question is, how can you tell that the length of AD is longer than the length of AB? So you can see that line AB starts at the center of the circle and goes towards the circumference of the circle, like right, the outer edge of the circle. But AD does the same thing, but goes further. So check this out. If I start stretching this line closer and closer to the center, right, eventually it becomes that line AB. If I continue going on the line, you can say the line is getting longer and longer and longer and longer. Therefore, this line AB has to be the shortest distance between the center point and the line M, which happens to be tangent to a circle. So the question for you is, well, why does this tell you that AB must be perpendicular to line M? Well, we learned previously the following fact. We learned previously that the shortest distance between a point and a line is a perpendicular line. So we know for a fact that the shortest distance between a point and the line must be perpendicular. In other words, when a radius meets a tangent line at the point of tangency, for example, the point of tangency here could be either point B or point C, then the radius and the tangent line are perpendicular, which means that it creates 90-degree angles. So I want you to write that down. All right, so that's the fun fact. So if you know a radius meets a tangent line at their point of tangency, remember where it intersects the circle once, they will create right angles. All right, it's week 2 password time. Now I'm going to tell you in the future. In the future, I'm not going to have a slide that's going to say week whatever password, because I want you to watch the whole video. I'm actually going to wind up saying like, oh, by the way, the password is whatever. So today's password, I'm going to write it out because a lot of you didn't follow the rules, the directions. You have to write it the exact same way that I write it, okay? The password for today is math is everywhere. With that smiley face, okay? Math is everywhere with that smiley face is the password, capital M, math is everywhere, with my special smiley face that I love using. All right, so we're gonna continue. Let's actually do an example. with this fact. So in exercise 3, this is what we're going to do. In circle K, segment AB is tangent to the circle at point A. Ooh, tangents and radii. If the radius of the circle has a length of 5 units and the tangent has a length of 12 units, then what's the length of KB? Well, why don't we fill in some of that information? So the length of the circle, the length of the radius is 5 units. So we got 5 units there. And the tangent has a length of 12. So the tangent line must be AB, because it says AB is the tangent. So that is 12. I don't know what to do. So I'm going to give you some time, pause the video, and I encourage you to try to do this on your own. What fact do we learn today? And then how can you use that fact? All right, so the only fact we learned today is when a radius meets the point of tangency of a tangent line, right? It creates a right angle. Therefore, angle A is a right angle. And then what kind of triangle is this? A right triangle. Whoa. And if we have two sides of a right triangle, how do you get the third side? Pythagorean theorem, right? The Pythagorean states the following: a squared plus b squared equals c squared. And we know A and B are the legs of the triangle and C is the hypotenuse. And remember, the hypotenuse is always the opposite the right angle. So this side must be the hypotenuse. I like to write hype. All right, so let's do this. Let's use the pen because that's a little bit more neater. Okay, so one of the legs, let's just say it's 5. So 5 squared. B is 12, so 12 squared. And do we know C? I don't. So, okay, my calculator ready. So 5 squared is 25. Plus 12 squared is 144. And that equals, so 5 and 4 is 9, 4, 5, 6. It's 169. So 169, right? 169 equals C squared. The inverse of squaring something is the square root. Because we're talking about distance, everything has to be positive, right? Because you might remember like plus and minus from algebra. But the square root of 169 is 13. Didn't even do my calculator for that. But if you need your calculator, that's okay. Because it takes practice to kind of remember a lot of these things. So, hi, Riley, how are you? Okay, so that means that the length of KB is 13. Now, if you knew that this is a special right triangle, a 5, 12, 13 triangle, you're awesome. But if you didn't, you're also awesome. Let's continue. All right, so we're going to learn something else. This is the second learning objective. In the following diagram are tangents BC and BD. Now, we already know that angles C and D are going to be right angles, right? When a radius, so like CA and AD, when they meet a tangent line at the point of tangency, they create right triangles, okay? So I'm going to just throw it out there. Why can we say that triangle ACB is congruent to triangle ADB? Again, I encourage you, pause the video and talk to yourself. Why do you think it is? Draw the picture, mark it up. Well, let's actually mark it up together now. All right, so they don't really give us any information. So let's go off with what we know. We know that there are right angles. And we know that the radius of a circle, anywhere you draw a radius of the same circle, it has to be the same, right? So A to C has to be the same as A to D, right? Because the radii of one circle is the same thing, okay? So we got an angle and a side. So hopefully you're thinking of like, oh, you know, side, angle, side, all those kind of things. But is there anything else in this picture that we can say? Yeah, so they share that side. But you might be saying, Mr. D'Souza, ASS or SSA, that's a no-go. You can't use that, Mr. D'Souza. But isn't there one case that you can actually use it? Riley, what's that one case?
Clearly, you can use that in a right triangle. It's called the HL theorem.
Okay, my cat says that if it's a right triangle, that's actually called the HL theorem, right? The hypotenuse leg. So if the hypotenuse is congruent to if you have two hypotenuses, or hypoteni, no, that are shared, and you have two legs that are congruent, and again, you only have a hypotenuse if it's a right triangle, then you can say the triangles are congruent. So these two triangles are congruent. So then how can you prove that the tangents CD and BD are the same? Now in my class, if you remembered, if when we were learning this, you were only allowed to leave the class if you told us the password. And the password was corresponding parts of congruent triangles are congruent. So if the two triangles are congruent, their corresponding parts are congruent. But what does that tell us now? It tells us the following. Boom. If two tangents meet at an external point outside of the circle, then the tangent lines are congruent. So to briefly just go over this again, right, if I erase this, and you know what? I'm going to do this on the fly. Let's make a new picture. Okay, so let's make some tangent lines. So remember, we have to have, let's use this, and let's use this. So I'm going to do the best that I can to make these tangent lines. Oof. These are not good. So we're going to use some video magic so that we can get there. Whoa, okay, so I've kind of fixed it. So we have line M and we have line N, and they both meet at, let's call this point E, okay? So tangents can go on forever. You can see how these lines go on forever, but we just learned a fact that if two tangents meet outside of a circle, that these, I'm going to highlight it with a thicker line so it's a little bit more obvious. Oops. Not the right color. We learned that this line is going to be congruent to this line. Those are the same. Okay, so if two tangent lines meet outside of a circle, from the point of tangents, from the point of tangency to the external point, the external point is the point outside of the circle that they intersect, right? So this would happen to be E. Then this is going to be congruent to that. All right, let's do an example. This is a classic example that they like to use a lot on their regions. Or actually also on the SATs, I also believe too. Exercise 5. In the diagram below, circle O is inscribed in A, B, C, D so that it is tangent to points D, E, and F as shown. Okay. If AD is 4 and BF is 6 and CE is 7, determine the perimeter. Perimeter, we're just going to add up the sides. Okay. And just like in any question, you got to mark up your diagram. Before I do it, I want you to try to do it. Okay? So I encourage you, pause the video, try it on your own first. All right, let's do it. So AD is 4. So here, AD is 4. BF is 6. Boom. And CE is 7. CE is 7. Boom. And determine the perimeter. Well, I don't even know what to do. Psych, I do know what we could do because there are two things that we learned. We talked about when a radius interacts with the point of tangency, and we also learned about what happens when tangent lines meet at an external point outside of a circle. There's no radius in this picture. So the only thing that I can think of is using the other fact. These are points of tangency, right? And tangent lines that meet outside of a circle, right? They're congruent. So that means this is congruent to this. So if this is 6, this also must be 6. Similarly, from DA and AE, those are also tangents that meet outside of a circle. So this must be congruent to this. So if that's 4, this must be 4. And finally, from E to C and F to C are also tangent lines that meet an external point. So EC must be congruent to FC. Okay, so if that's 7, this is 7. And if you want to find the perimeter, you need to add up all the sides. So let's do it. We got 4 plus 4 plus 6 plus 6 plus 7 plus 7. Take out your phone or calculator, whatever, put it in. Is 34. So the perimeter is going to be 34. A reminder, please look at the schedule that we posted on Google Classroom. It's going to be super helpful when you're trying to plan out how to do all the work. If you need anything, please let us know in advance. Come to office hours. We are here for you. I hope all of you have a great week, and I hope to talk to all of you soon. Goodbye, everyone.